Um, Hello everyone. This is gonna be lecture 2, and so this is lecture 2, as I said. This is on our last test, which is include two different tests, but they're very similar. So this is what we're gonna call the ratio test and the limit test. They're both important, and they're both can be applied to certain series. Okay? And so I don't know why you're not seeing me. Is that better? Okay. I hope this you can zoom when you watch the video. I want to make sure you can see all of me. So I'm trying to make it as much natural as possible to the classroom lecture. All right, so I think I will be giving you a quiz. No, we need to give an exam. So next Tuesday, be ready for the exam I promised you, and that never materialized. So hopefully next Tuesday, that is a week. Today is Monday, right? So let's, how about we do the exam on, okay, do you want it, let me know if you want it on Tuesday or Friday. Or Monday, may I say. So to be fair, because we're running out of time, let's have it on Monday, next Monday, a week from today. What I will do is I will upload the exam to I'll tell you what, we were told by the university to stick to regular schedule. So the exams will be on Tuesday. Sorry. So one class will be during the regular time on Tuesday, remember? So your classes will be on a regular time. So what I will do is I will upload it to Isidore. You go in and start the exam, and in 2 hours I will give you instruction. It has to be submitted to Isidore by that certain particular time. Okay? I guess we're gonna have to treat you like you're an adult, and I'm sure you have no intention of cheating. So please keep it that way, and I really trust you. I just want to mention that I have not gotten any instruction from the university regarding examination. So not only the math department, the rest of the university. So I'm gonna do my own rules. I'm gonna put one for you on Isidore and go for it. I don't think I can wait any longer. I have opened all the skill tests. Make sure they're all open, 2 and 3. Please try them. One guy told me 2 require password. I don't know. Please try it. They should not require password. Okay? All right. If you have any question, email me. Tomorrow is Tuesday, right? Tomorrow I will log in during your regular class time, whether you are section 2 or 3. I will log into Zoom, and we will have like a problem session. You ask me question, I will answer them. All right, that's tomorrow. And I'm hoping Farwick will have one with you on Thursday. Okay? All right, and so on. Again, let me know if you have any questions. Okay, so we're gonna lecture on, as I said, we're gonna lecture on the ratio test. So this is R dot T. Okay? Ratio test. The ratio test says the following. Consider this series. Let's say we start at 1. Doesn't really matter as long as it's defined. n equal 1 to infinity an. Okay? So it's the ratio. So 1 if the limit as n goes to infinity in the absolute value of an plus 1 over an is less than 1. So that ratio with the limit. So basically you take an, you replace n by n plus 1 and divide it by an and take the absolute value if this has negative term like alternating series. And this is if this less than 1, then an converges absolutely and hence it converges. Why? Because last time we proved that absolute convergence implies convergence. 2, if the lim as n goes to infinity of an plus 1 over an is bigger than 1, then an, what do you think? Diverges. Okay? I don't know. I hope you can see the board. All right? So 3, if the lim as n goes to infinity of an plus 1 over an is 1, then the test gives no information. No information about convergence or divergence of an. Okay? So this is where we are. All right. So let us so let's go over the test again. It's called the ratio test because you take an plus 1 over an. So that's why it's called the ratio test. And so you take the absolute value for an plus 1 to form it. You replace n by n plus 1 divided by an itself. Take the absolute value. You must simplify. And then if the limit has, as you can see, all those cases, okay, the limit less than 1, an converge, bigger than 1, an diverge, actually the sum equal 1, the test is inconclusive. Inconclusive means more work, look for different tests, okay? All right, so what do you think? All right, so remember, this is a test. Okay. All right. Okay. So let's do some examples. Okay? Let's say we want to test, this is very important for exponentials, for other things, and so forth. So let's say we want to do n equal 1 to infinity, okay? And e to the minus n. Okay? Well, if you do, this is not an alternating test, alternating series. You really cannot compare it, I don't know. So let's apply the ratio test. So here, an is n e to the minus n. Is that right? So what is an plus 1? an plus 1 is n plus 1 e to the minus n plus 1. So now let's take a look at the limit as n goes to infinity of an plus 1 over an. And that's going to be the limit as n goes to infinity, n plus 1 e to the minus n plus 1 over n e to the minus n. So, right? All right. So, the best way to do this is to simplify it. So, let's do, this is the limit as n goes to infinity, n plus 1 e to the minus n times e to the minus 1 over n e to the minus n. You see e to the minus n over e to the minus n is 1. So that is the limit as n goes to infinity of n plus 1 over n times e to the minus 1. So let's take this limit. So this is e to the minus 1, the limit as n goes to infinity of n plus 1 over n. That is e to the minus 1 times 1. But that is 1 over e, and that is less than 1, isn't it? So, by 1 of the ratio test, n equal 1 to infinity, n e to the minus n conversion. You know, here it doesn't make any sense to talk about absolute conversions because there's nothing like alternating series. So, when there's no alternating series, there's no need to test for absolute conversions. Anyway, but this test gives us automatically absolute conversions, but this series is always positive, so absolute conversions are the same. How are we doing? Think we're doing okay? Well, I am doing all right. Okay, so let's, so I don't know, if you look around my house now, I work out of the home, my wife works out of the home, Venetia works out of the home now, so my house is like a whole big office, okay? All right, so maybe we'll do another example. What do you think? Well, let's see. Okay, here's an example, then we can take a break. Will be our first video. Let us try n to power n over n factorial. And let's go from n equal 1 to infinity. Take a look at this. You see it? Zoom on it. Okay? So this is n to power n divided by n factorial. This is going to take us some work to do, but it's going to bring back some stuff you learn in Calc 1, where we use some indeterminate form when taking the limits. All right, so here an is n to power n over n factorial. Okay? Okay? So let's take a look at, let's do an plus 1 over an. Let's not put the limit now, because let's simplify this first. Because if you're going to put the limit, you have to do it every time, and this is going to be so many steps to simplify it. Okay? All right. So if I do an plus 1 over an, so this is n plus 1 to power n plus 1 over n plus 1 factorial divided by n to power n over n factorial, and that is n plus 1 to power n plus 1 over n plus 1 factorial times n factorial over n to power n. So this is what you can write this one. Don't worry, I don't have corona. I do have a dry cough though, but that's okay. I'm fine. All right. We need to simplify this a little bit more. So the thing is to simplify n plus 1 factorial over n factorial. Or the other way around. So let's simplify. So let us take a look at n factorial over n plus 1 factorial. And you will see this is 1 times 2 times 3 times n. The n plus 1 factorial, if you take n equal 1, you'll get 2 times 3 times n plus 1. But 2 times 3 is the same as 1 times 2 times 3, is that right? So this one and this one, so all this one over this one will cancel, will be 1. So this is 1 over n plus 1. How's that? Do you see this? Okay? So this is what we have. I hope I'm taping. If I'm not, I'm in big trouble. All right. So let's get back to our simplification. I'm fine again. All right. So this is n plus 1 to power n plus 1. Excuse me, guys. Over n to power n. So that is this one here. And this is n to the n. So the n over n, we decided this is 1 over n plus 1. Remember? So that is n plus 1 to power n times n plus 1 over n to power n times n plus 1. And you see this will simplify. Take a look at it. Thank you. Sorry. All right. I usually, when I sneeze, my dog run to me and start loving me and kissing me and everything. Lily, I've been sneezing. I don't care, Dad. I got a bone. All right. So this one is n plus 1 to power n over n to power n. And that is n plus 1 over n to power n. And that is 1 plus 1 over n to power n. Take a look at it. Do you remember those of you who had me in Calc 1? Do you remember this? Do you remember the limit? We need to take the limit. Okay. Thus, the lim as n goes to infinity of an plus 1 over an is the lim as n goes to infinity of 1 plus 1 over n to power n. This is where we are now. Okay? And we need to do something with it. Alright? So, how is that limit? This is an indeterminate form. So what we're going to do is we're going to let y equal 1 plus 1 over n to power n. That means ln of y is n, ln of 1 plus 1 over n. And I'm going to rewrite this as ln of 1 plus 1 over n over n. Okay? So, the lim as n goes to infinity of y equal the lim as n goes to infinity plus 1 over n over n. And that is the lim as n goes to infinity of ln of 1 plus 0 over infinity, and that is 0. So you're going to get 0 over infinity. So, thus the limit as n goes to infinity of 1 plus 1 over n to power n is basically e to power the limit as n goes to infinity of ln of y. Okay? Of ln of y. So this is e of that, and that is e to power 0, and that is what? Ugh, all this work, and guess what happened? The test. Actually, we're getting 1 here, so the test failed. Okay? So we're gonna end our lecture here, and I will come back with another lecture very soon. Well, I guess you don't know. Maybe you'll know from my clothes if I did it on the same day or not. All right. See you later. Thank you very much for watching. And please, please, please keep up with the work. I will give you homework at the end of the second video. Thank you. Be safe.